So this is Carola Di Alessandro again. With this talk, I'm not acting as a project manager, but just as a proponent expert, as somebody who has been doing some side technical work to provide more insight for the TI team to evaluate, to be further evaluated. So Jennifer showed an example of forward applications of GMPs by, let's say, plugging either local segment rakes and dips or parameters that have been averaged throughout the complex fault. So she already covered what are the options for accounting for variation of rake and for dip and rake along strike. So I'm going to refer as her presentation. But what we are really what I would like to show here is to understand if there are any constraints on which of the methods that Jennifer proposed would better provide a fit with the observed data. So what are the data available that can help us constrain which of the proposed approach works better, and then try to quantify what the potential effect could be, again, only looking at the empirical data available. So I thank so much the NGA West 2 developers for providing the residuals, which I just started digging. So it's not an exhaustive presentation, but yet it's the beginning of the analysis. And we are going to focus for this talk to results that have been derived using the Abramson et al. Model and the Chu and Yang's NGA West 2 models. So in deriving conclusion on if the data are sufficient to constrain the effects and if the effects are big enough that it matters, I'm going to evaluate goodness of fit plots, and then I'm going to be drawing some conclusion for possible path forwards. So for the people who attended the workshop one, this was an excerpt of the presentation that Jennifer presented. She was going over the available empirical data for complex ruptures. So this is, okay, here. This is the list of all the events recognized with complex ruptures, so with multi-faults, and then she had also disclosures on the events that were not included in the analysis due to not noticeable difference in rake or dip. So we took the analysis further, so we applied further constraints. We selected only those events which show changes in rake and dip, and not only strike. So some of these events have a variation in different segments that appears in the strike direction. Strike is not one of the explanatory variables in our GMPs, so I'm not accounting for those events. And also another constraint, these events should have some recordings within 20, maximum 30 kilometers from the complex portion of the fault. So we really want to understand if the effect can be quantifiable. And then in order to be sufficiently represented in the residuals, of course, these events have to be selected as a subset by the people who developed the NGA West 2 models. Okay, so after this sub-selection, we ended up with a handful of events that can be used. And again, those are plots borrowed from Jennifer's presentation in workshop one. You see that we ended up with 5 events that we can work with: El Mayor Cucaba, Wenchuan, Chichi, San Fernando, and Kobe. Here you have, except for Wenchuan, plots of the complex segments and also of the available stations. These are all the stations around this quadrangle, and we further refined only those stations that were within 20 kilometers. Only for the San Fernando case, we extended up to 30 because there was paucity of data in the near region. So we tried also to quantify an element that can help us, again, evaluate the impact of the changes in rake and dip. So here we evaluated a parameter called delta rake and delta dip, which is basically the difference between the suggested average value that is as appearing in the NGA West 2 flat file, and then the closest segment, and that would be for each of my sites that recorded that event. Is that clear? We don't have to repeat. Okay, perfect. So, and one thing that I want to add actually is that while talking with the developers and asking what was the philosophy that they followed while choosing either the average parameters or the local parameters, admittedly, several of the modelers except Norm admitted that it was a matter of commodity because it was the parameter that was provided in the flat file and there was no formal robust evaluation on which of the two sets to utilize in the model building. So we're trying to provide some information that can be helpful also for the modelers in their future evaluations. So here we see the frequency of our delta rake and delta dip within the events that we considered. So I just want to show you that we have at least a big contribution from Chichi. Chichi has minor changes in dip, but it doesn't have changes in rake. It's pretty much a strike slip, just changes strike, but there are minor changes in dip. So
not strike slip, it's reverse. Chichi.
Chichi, yes, sorry, yes, correct. So well, anyway, the delta rake doesn't show in the subset. It mainly contributes to the changes in dip. And then we have other minor contribution from the other earthquakes. Wanted to let you know that the earthquakes that have, I'm sorry, this legend was a little messed up. But the earthquakes that have the best use for us are the El Mayor and the Wenchuan, where we have noticeable variation of rake and dip. And I'm sorry that this is not showing correctly. So I wanted to present our residuals in a meaningful way, and I tried to select two periods, 0, 2, and 1 seconds, and I plotted my residuals versus delta dip and delta rake, delta dip, 0, 2, and 1, and then also versus delta rake. Now, in red, you will see the residuals for those stations which are located on the hanging wall. I admit I didn't plot the entire ensemble of my residuals versus for the different earthquakes all lumped together versus delta dip and delta rake because I was interested in the fact that they were more event specific, but that's something that can be done to see if there is any trend that can be recognized in the residuals versus the parameter delta rake and delta dip, but that's something that can be done.
While Yusa's waiting for the microphone, I don't understand what you just said.
So these are the residuals for the event Chichi. Something that I could have done, but I didn't do, was to use all the residuals from all the events that show these changes in dip and rake and plot them versus delta dip and delta rake. So to notice if there is any sort of trend in these residuals.
So why didn't you do that?
Paucity of time, and also because I was more interested in the event specific.
That wasn't what we wanted you to do anyway.
Yeah, it wasn't. Thinking if that could provide further information. If not, that is fine. We can move forward with what was done.
Let me address it to say what I think you're going to show, just so that we're trying to see, can we explain the residuals better using the average values or using a local value, right? That's what you're going to be getting.
Correct,
okay.
Yes. Okay, and so here you see the residuals for the different modelers. Again, these are all referred to Chichi. I have similar plots also for the other complex events, but again, for interest of time, I'm just showing Chichi. So this is for the Abramson et al. Model. This is for the Chu and Youngs. This is for the Campbell and Buzornia. Again, you can have a good view. And then for the BSSA model. Okay, this is a one way of plotting the residuals. Then I tried a special plot to see how the variations in deep and rake were clustered. And I know that it's difficult to fully appreciate the depth of the figure, but what can be drawn by this figure again is that there are clusters of data, and this really reflects the fact that we have different segments. One thing that maybe it's easy to, for evaluating this picture, this plot, is to break down into changes of delta, deep, and delta rate. This column would be for 0 to seconds, and this would be for 1 second. So pretty much this is what comes out when we break this 3D plot into 2D. That is just another way of visualizing our residuals and how they distribute.
Just a second, the top, what's the difference?
Okay, so this is another, okay, so one step back. Chi-Chi didn't have changes in rake, okay? So it was very easy to do bidimensional plotting. In the case of El Mayor Cucapá and Wenchuan, we have simultaneous changes of rake and deep, and that's why I'm providing this sort of three-dimensional plots of my residuals. But in order to improve the visibility, I'm also breaking it down. It's like slicing, okay, this plot, just considering the residuals versus deep, or the residuals versus the delta rake. And this is what is shown here. This is for the event El Mayor Cucapá, and I'm showing the residuals for the Abramson et al. GMP. Again, this will be for 0 to seconds, and this is for 1 second. Delta deep and delta rake. And again, in red are the sites on the hanging wall portion. And then I can scroll. This is for the same event, but for the Chu and Yangs. I can give you a few seconds to appreciate the plots. And then this is for the Campbell and Bozornia and how they distribute. And again, it's noticeable that events, the recording contributes towards changes in deep and rake. That's why here you can really see and appreciate the presence of different segments that contributed to this evaluation. And this is for the Boer et al. Model. They had less data for El Mayor Cucapá within this distance. Okay, so moving forward, what could be a simple but yet reasonable approach to evaluate which methods or which choice of fault parameter works better? So we want to compare our predictions with available observations. So this is just to guide you through the analysis that I performed. So in my cases, I computed my predicted spectral values using, again, Abramson et al. And Chu and Yangs. So on one time I used the local parameters for the Chu and Yangs, or the average fault parameters for norm, because respectively the modelers used the local and the average. So I just complete the evaluation that was not done. Then I evaluated the ratio among the two predictions, and I used that ratio to adjust the intra-event residuals. That is done on a period base and for each side, for account for that ratio. And then I evaluated the mean of the residuals, either using the local fault parameters or the average fault parameters. And then I also computed the standard deviation and the 90% confidence interval. Okay.
So,
yeah.
Is this simply saying if I used local parameters, I'm going to get one average residual? If I use average parameters, I'm going to get the next, because I wasn't quite...
Yes, they are color-coded. That is just to guide you through the process, but here probably you can see better the application. So sorry that the rendering is a little blurry, but this is for El Mayor Cucapá. So in the case of Abramson et al., the red solid line corresponds to the mean of the residuals for those sites that express changes of rake and dip along the strike. Okay. Then we also have the confidence interval and the standard deviation, and it's just difficult to see, but that will be the range here. Then I used the ratio between my predicted spectra to adjust the residuals, and the median of those adjusted residuals is the solid line in blue. So these represent the mean bias using the average segment. Those are my adjusted residuals. Okay, and again, my evaluation, or something that I want to provide the TI team for evaluate, is which of the two approaches yields to better agreement with the observations. So overall, with a smaller bias throughout the period range. For Chu and Young's, I applied the same approach, but in this case, vice versa, because they originally defined their GMP for average parameter. So I computed my predicted spectral acceleration using local rake and dip, then computing the ratio, using that ratio to adjust their intra-event residuals, and then finally providing a median. This type of plot is very similar to what was performed for the SCAC broadband platform validation. So if you were familiar with what Christine showed and what also Doug discussed, this is the same type of plot. In the case of Chu and Young's, we can notice that the effect is very minimum. The two median lines, so the red and the blue, are pretty much collapsing one on top of the other. This is the case of El Mayor Pucallpa. We had 4 hanging wall sites within this distance that we considered. The changes in rate were from a maximum of -74 to 16, and we also have changes in dip between -12 and 18. Something noticeably, for this event, while accounting for the different segments, we have 3 changes in style of faulting. So three sites that have changes in style of faulting when we account for local segments versus the average segments. And that's why we have some noticeable effects. If I move forward and looking at Wenchuan, again, you can see here the effect for the Abramson et al. This line here is 0. Okay, this is the mean residual using the closest segment, so that will be the original intra-event residual, and the blue line is the mean of my adjusted residual using average fault parameters. So you can appreciate how it changes with respect to the original mean. And again, for Chu and Young's, the effect is very minimal, barely noticeable. Chi-Chi, okay, you also see the results. This is the 0. So it seems that using the closest segment parameters, at least for the Abramson et al. Model, we have better agreement with our observation, at least for short period. And again, for Chu and Young's, the effect is not statistically or also visually noticeable. So when we include all our events that have shown changes in rake and dip, and we average our mean bias, this is what we obtain. For Chu and Young's, pretty much the two approaches fall one on top of the other. There is no statistically significant differences. Here you would see what is my mean bias using the closest segment and the average segment, so that would be a line more or less following here. And what would be my absolute bias, again using closest segment or average segment. You see these numbers are very, very close. When we look at the effects at Abramson et al., we can notice some period-dependent improvement of the agreement with observations. Again, it seems to be better agreement at the short periods. At long periods, it doesn't seem to provide a strong effect. But yeah, that is something we want to provide for further evaluation. So again, these are the conclusions.
Carola, one question.
Yeah.
So you're going to repeat for other GMPs also?
Yes,
Oh, okay.
yes, correct. So this is the look for the future. So they evaluated the effect for the other two NGA-West2 GMPs, and again, they were not addressed for paucity of time. And also, we want to really have an understanding if we have sufficient data to constrain the effect. And by looking at the available data, it seems that our data set is not as robust as desirable to constraints. So we need to augment our empirical observations with simulations. And that is something that will be done in the proceeding of this, moving forward with the project.
That's really the key out of all this.
Yes.
The empirical data can't tell us.
Yes.
So we got to, and if Cho and Youngs had redone their evaluation, they would have got the same model out,
Yeah.
basically. And I would expect similar results for the other one. So that brings us to the question, if the simulations, which now have a much richer database, are showing a difference, what approach do the modelers want us to use in not fitting data, but in the forward application of the model? And is there a reason for that? Right.
What is the rationale? Yes. Okay.
So that's probably our discussion topic. Where you want it,
Yes. Okay, I'm finished. You can.
That was your last slide, wasn't it?
Yes, it was. It was. I'm just toggling back and forth. Yeah.
References.
Yes. Here. Of course.
Did you use event-corrected residuals?
Yes, correct. I use intra-event residuals. Now, something that I discussed with Brian, but not as a speaker, but just as a modeler. The robust approach to get to this effect would be to re-regress the model either using the local fault parameters or the average fault parameters, and evaluate the event term, removing that, and then evaluate the intra-event residuals. The approach that I presented, it doesn't follow that procedure, but we, at least my proposal out of that is a simple but yet reasonable approach to evaluate the effect of these changes in wake and deep, and the modeler's approach.
That's technically correct, but given the sparse amount of data, unlikely to change your conclusions.